Hi everybody, my name is Gunnar Schomaker. I'm from the SICP and I will now it. So, okay, but to have an impression on what happened last 20, 30 years is you have to look at technology evolution in two areas. And one is here in 1971 where the 4004 was introduced, and then to the 80s where memory was a topic, and then in 2000 where you could identify something like a head-up of two technologies where the digital all-in started, and then in 2010 where we had a lot of virtual machines, let's say machine, but no weight. So, and in 2020 the topic sustainability appeared. So, and we were more or less clueless how to derive sustainability in these designs we had. So, but we made it. In 2030, we found a way to say, okay, this is a good approach, let's do it stepwise and become more sustainable in the digital society. So let's start in 1971. The evolution of the microprocessors has more or less started. But in 1946, a little bit earlier, every one of you knows maybe the ENIAC with 500 flops, 10 times 17 meters of size and 27 tons. Yeah. So, and then as said in 71, the first transistor was CPU, the Intel 4004 was introduced with 4004 transistors. And in 1976, yeah, just 5 years later, yeah, the Cray 1 appeared. Not that much weight, 5.5 tons, not that much size, 6.5 square meters, and the performance tremendously increased by 160 million flops. So, and compare this to something some of you might have on your hand, to what time we have, or to look at your blood pressure and oxygen and so far, but of size 40 times 34 millimeters and 25 up to 40 gram, and the performance of 3,000 million flops. If we compare this to the Cray you are wearing on your hand, 18.75 times a Cray, quite heavy, and 6 million ENIACs. So it becomes very, very dense. Where are we now? So if you look at the Oak Ridge National Laboratory, this is where multiple of current available computers and servers are working. So this here is a performance. Still, again, a lot of square meters and roughly 2 tennis courts and huge weight, 340 tons, but we are now at 148, around about 149 petaflops. What does it mean to have 150 roundabout petaflops? That means if every human being calculates one operation per second, yeah, mankind needs 1 year to provide 1 second of the computation power of the Oak Ridge High Performance Computation Center. So this is a lot of power compared to what we can do. So, but where is this needed? Yeah? It's needed for simulation. For instance, here used for hurricanes. Yeah? And it needs millions of core hours computing to get these results, to understand how a hurricane is working. So, and this generates several tons of data, terabytes of data, and clearly you have to put it somewhere. So obviously it's not enough to evolve and have a good technical evolution of the CPU side. The necessity of storage and how to deal with the storage also came into the focus, but in 1980 more or less. In 1956, 5 megabyte, 24 inches 500 kilograms and 10 kilowatts by the IBM hard disk. Here you got the impression of what it means to move storage. Yeah? In 1980, we have the Seagate with 5 megabytes with 5.25 inches. Maybe what some of you can remember these drives. I've got one, and I still have one, and I have rebuilt it to a clock. So, and if we bring this into comparison with something, you can say, okay, in 1980, 10 megabytes, let's say here on 26.6 centimeters, this is 2 of these units, yeah, transferred to 1992 in a typical size, like 2 gigabytes, yeah. What is the compared size? Yeah? And if you look at it, it's very, very tiny. So, and yes, 10 megabytes compared to 1980 is 0.06 centimeters. Yeah? Have a comparison on this. The small vinegar fly has a size of roughly 2 or 3 millimeters. So in 2001, we already reached 180 gigabytes. In 2006, Samsung introduced the SSD, a variation of how hard drives are constructed without mechanical components. And in 2019, we reached 16 terabytes, yeah, on 3.5 inches. This is a lot of storage and a lot of capacity. So if we look at 2019 with 10 megabytes, well, what does it mean compared to the 10 megabytes in 1980? You can imagine it's still very, very tiny. So how big it was? Let's resolve this. It was like having 11 nanometers. To have it on a comparison, visible light is here. This is a spectrum, and we have the red and the green. The green is roughly at 550 nanometers. Yeah, so if you look at this 10 megabytes, in 1980, 26.6 centimeters. In 2019, 11 nanometers. I'm not talking about the storage density on the platter and something like just the frame compared to that the form factor. Yeah. So if we go further and make an example out of this and say, okay, let's travel to the past with the requirements of 2019 and say, okay, let's go to 1980, but without the Seagate. Yeah? So it's not like we are importing technology into the past, sometimes happen in Star Trek. And very important is if we do this journey, we want to do this for sure. We are now a sustainable society. We want to do this CO2 neutral. So this is the best vehicle we have for it. Clear, everyone knows in the 80s. So we had a hard journey and we arrived in 1980 with some memory gaps. But we remember there is a customer in the near future and he needs roughly around about 16 terabytes of storage. So the task for the engineer is, okay, start now, pile it up. Yeah? And doing it a while, let's say we recognize, we are reaching up 361 kilometers, and we recognize this while the ISS passed us. So we can see here, this is a rendezvous point in the elliptical transfer orbit. It's by 350 kilometers, and we are just past this point, and just 1,000 times more of stacking, because if an engineer starts something, he's not stoppable, because actually we cannot shout at him, he's too far away, so he will continue. So at least 1,000 times more, he reaches the moon. So 1,000 times 16 terabyte. Yeah? That's not much storage compared to that what you can see now in the market. So let's travel back into 2019. and look how is the market situation. So we can see that in this area 100 million units per quarter were sold. So that means if you here see the distribution in the market from 2008 to 2019, if you sum it up, you reach 5,846 million units sold of storage. Some of them are still working, but not all of them, but a lot of units. If you compare this to something else, what is big, it needs more time to build, is the Milky Way. Let's look where it gets important. So the behavior in this technology evolution or universe had changed. So in 2002, we say the digital area was more or less started. So 50% of the information is digital now. So, and everything what is new comes into this game as digital. And in 2017, 90.9% of the information is now digital. So we have something like an all-in. And in 2000, a technology head up more or less on the storage and on the CPU side, on the server side, had started. So because we had to think about how storage parking spaces are getting manageable. So, and something happened, every one of you knows it, is a RAID. In 1988, it was introduced as a redundant array of inexpensive disks. So later it was renamed to independent because, as you might imagine, in 1988 hard disks were expensive, and the concept behind, I won't explain it now, everyone knows more or less, the independency was more important to reach the availability. So, and in 2005, this virtualization, the storage virtualization, the virtual storage drivers were standard in a PC BIOS. So it was more or less a part of the DNA that storage reached a logical view, and it was not visible anymore on a physical layer. So the scheduling and the allocation was on an abstract layer. So, and then something appeared because it was handleable. Dropbox in 2008 appeared because Amazon S3 also made his service or their services available for others to build up businesses. So storage as a service reached the end user. And also other features like deduplication and so forth. So, and in 2011, iCloud also appeared in market, but the synchronization was more in an application context. And later in 2014, the iCloud Drive made also synchronization, but with an, let's say, intelligent eviction strategy, so that this redundancy in storages was reduced on the user's side. So very, very interesting. But at the end, you have to ask, if you're talking about end users in let's say, human dimensions, or how many storage do you need? So if you look at 1985, a limit was given by PC-DOS, like no one needs more than 640K. This is not much. We know it's not right. In 2020, it was estimated by around about 1 or 2 terabytes of data. Later we had learned in 2030 that was not the end of the story, because everyone needs more or less 16 terabytes of data, because now everything is digital. We have a lot of digital twins to operate optimal and sustainable, and all these environmental footprints on the digital, let's say, surface creates tons of data. And because of the idea of having privacy and this more or less protected, everyone has to store it more or less in his own container. So, and this is more or less 16 terabytes. So this is the story of storage. So this ecosystem to use storage, to have it in a handleable, in a convenient way, was started by the virtualization concept of storage. So, and it was an important step. So, and on the other side, in 2010, these machines without weight appeared, and with a lot of features came into market. We say virtual machines now, or now we are talking about microservice architecture and so far. You might know this, so but it's not that important. The important thing is that it's more or less the same. In the early phase we had dedicated systems with dedicated services, and suddenly we were able, because of the tremendous need of more performance, to virtualize this by having something like a hypervisor, which is running a lot of virtual instances which are, let's say, behaving like I'm a physical one. You can do with me the same you can do with a dedicated one. So, and this gives us a lot of flexibility. But what's behind this idea is, here we still had very huge virtual machines, and the containers, the Docker idea, made them, let's say, more tailored, smaller. So the container only have that what you need to run the application in your environment. And this also gave a lot of flexibility, and at the end, this tailored suite for application allowed us to recombine a lot of services to a bigger solution. So it was at least a modular concept. So we were able to have like Lego systems, or to put and plug everything inside what we need, and not more. Yeah, not over design, just that what we need. Yeah, the requirements were the most important thing. So, and that means that the living space of services now are platforms. Yeah, so, and at the end, the sales unit, yeah, the product of the service, is at least that what the sales unit is. So it's not anymore the physical layer. It's the outcome of the service. So because it's demand driven. So only the outcome is that what I'm interested in, not in the way how it is constituted. And this allowed us to have a huge ecosystem of different platforms, and we made them more or less interoperable, and we realized that this resulted in a huge geographical compression. All these huge data centers appeared, and the stress factor of energy and waste heat was still unsolved. But nonetheless, we also recognized that the bandwidth and the latency became increasingly important. This needs to be solved somehow. And yeah, there are opportunities to solve this, but let's look at it in a different way. Because at the end, what we reached is more or less something like an environment where everything was possible. Everything obtained a service, like electromagnetic levels, or water leakage, or vehicle auto diagnosis, and all the things, waste management, smart parking, a lot of services in the local area. Yeah. So, but what does it mean? Why became this important? Let's look at the traffic side of this. Yeah? In 2019, here you can see how the traffic was more or less distributed. So 50% was on mobile phones, because it was a habit to have everything with you. Yeah? And if you now look at online content activities, we also could see that 98% of internet users who consume their content by internet are watching videos. Yeah, so this is a huge number, and so if you look at this, what is the most important part here is everything was cross-linked. Yeah, humans with humans, humans with machines, humans with environment, machine with machine, machine with environment. So everything was cross-linked. So, and the question is, where should we process the data? So is it wise to have it in a central manner, or decentral, global, regional, or local processed? Yeah. What opportunities do you have? Do you go into a huge location? Yeah. Or do you go to, for instance, cloud and heat? You go into a container. Yeah, or do you go to wind cores? Yeah, in a windmill. Yeah, so how to make this decision? Yeah, so, but if we look at sustainability in a service and we focus on energy, just focus on energy, yeah, the data processing could be decentral, local, coupled, and by this then cheaper. Why? Because move to the sustainable energy, yeah, is possible. Yeah, information is weightless. Yeah, infrastructure for energy and so far is not that weightless. So supply at the producer is possible. You can move to the energy producer. Yeah, supply within the producer, if it already provides a facility, is possible. Yeah, and coupling sustainable heat sinks is also possible. So you can use existing heat sinks, or the best thing is use the waste heat, so that you have multiple usage of the energy, but in different forms. So this leads to sustainable behavior and sustainable society, using that what you have, not building all the time everything new. So, and that means this leads to a sustainable, let's say, option. Let's say option, yeah? Because you still have to decide by the demands of your end user if this is a good way or not. So, and if you look at the thing within the producer, let's have perspective on wind energy, or let's say sustainable energy in our area. So if you look, we have 244 terawatt hours produced by renewable energy sources, and 5.4 of this energy, terawatt hours, is thrown away because we are not able to connect it to a potential user. This is another problem. We have sustainable energy, but we are not possible or not able to use this energy. So, and it is feasible to serve 1.7 million households. Okay, what is a perspective and concept? Is to go into a windmill. So this is a solution already running since 2018, and it's still running. You can see it. It's a museum. Yeah, clearly in 2014 we want to know what was our first prototype, and these are the concepts we are building now. Till the last 20 years we have classical approach, multi-level concept, where we can more or less place everything inside which comes to us by a rack. Energy is no problem, we have enough. So, and but as you might have observed before, we have this tremendous use of videos, and this has not changed. Even this presentation is given you by video. So streaming, how to become sustainable in streaming. So who was the first? Zetto was the first, yeah, in combination. But why? Yeah, what is Zetto? Some of you might know. It's a TV distribution over the internet since 2006, and it's a pioneer in Germany and Swiss. So, and they operate multi-tenant TV as a service platform, and they have roughly reference customers like 1&1 or Sold, you may already know, still know. And Zetto in numbers is 3 million monthly users and 1 million simultaneous users. So 15 petabytes of individual data images are produced. So, and they are running in 2019-20 roughly 400 servers. And they were located in Frankfurt and in Zurich. So, but why made they this step into the wind cores? Why did they move to the wind cores? Because they thought steadily growing needs of energy, and it was difficult to meet their needs with the solutions in the data center. So, and they had an openness for innovative solutions like the wind cores, and they said, let's give it a try. And they started this, and here you see one of the early pictures where they went into the prototype, and they said, let's use the energy where it is generated. This is obvious for us, so let's do it. And why? Because they had also sustainability goals. They want to get CO2 neutral in 2020, and they want to reduce their CO2 footprint in every area they are operating in. So, and so at the end, they have also recognized that the wind course concept, because of the potential of cooling by the windmill facility, was much better than doing that by extra infrastructure. And and another thing clearly is you want to be an innovator. You want to say, I've done something cool no one have done before. So and you know, if you have made already innovations, you are more sensitive to this and to see and to take these opportunities. So and this is only then possible if you just do it. Yeah. So they made it. So, and this was the first step. They were the first who moved into a huge reference that moved into the wind course, and they said, let's do it that way. There were other approaches, and they have followed this idea how to reach a sustainable society. So in 2030, more or less, a lot of market players has adapted to this strategy. They use cloud and heat, they use wind cores, they use wind cloud, but they were sensible for sustainable places. Yeah? Sustainable places where you use what you have to run IT best way, fit it to the requirements of the end user. So this is my talk. I hope I have used 40 minutes roughly, and we have some times for question, and I switch off